listen to somebody talking about contract testing, like testing in general. That's already something. So I really, really would like to thank you. Who am I? My name is Marcin Grzejszczak. I have a terrible name to pronounce, the last name. But other than that, I'm the creator of Spring Cloud Contract. I used to work at the Spring team for 10 years. So if you're using, so who's using Spring Cloud Contract? Anybody? One person, great. Who knows about Spring Cloud Contract at all? Okay, good, some people. Who's using micrometer tracing? Oh, okay, so that's, if stuff is working, that's because of me. If there are bugs, it's the observability team. I'm a Java champion. I've done over 150 presentations, workshops. And I'm here thanks to Hero Devs. I'm working there now. So if you have old, sad projects that are using unloved open source projects that are out of support, talk to us, because most likely we've already patched them. No CVs, you can use them. And I'm blogging at toomuchcoding.com. Okay, Spring Cloud Contract 5. That was a housekeeping release. So when I quit the Spring team, it's interesting because finally I had some time to work on this project because, like, you know, observability was the critical thing, and finally I could spend some time on my baby because I created from scratch. It's also not a very young project. It's like 12 years old now because it used to be called Accurate before that. In general, in Spring we have this approach that when we have breaking changes, we can always only do them, or we should only do them in major releases. So it turned out that, hey, there's a 5 coming up, so it's time to break. I didn't provide any features, really. It was a maintenance release. There were certain decisions I had to take, which I postponed for years. First of all, WireMock 3. So in the meantime, everybody had WireMock 2. Who knows WireMock? Okay, everybody, almost everybody. So WireMock is a project, a Java project, that allows you to stub an HTTP server. And we had WireMock 2. That was like end of life. There was WireMock 3. There were breaking changes, and we couldn't upgrade. So finally, the decision was there. We can finally do it. So if you're migrating, remember the group ID for WireMock has changed. Java imports stayed the same, which is why it was a little bit frustrating because there's like literally nothing theoretically blocking us from migrating. But there was, right? I mean, because of the dependencies. Now, I believe, like I have this approach in life that it's absolutely fantastic to push my problems to somebody else. Why should I take care of my problems if somebody else can take care of them? So, since it turned out that WireMock has created an official Spring Boot interaction, why should we have our own in Spring Cloud Contract? So what we did is we removed the the Spring Cloud Contract's WireMock integration. So you used to do auto-configure WireMock, and now who is using Claude or any other tool like that to code? Okay, good. So now if you say, hey, Claude, could you please create the Spring WireMock integration, or like I have a Spring project, I would like to test it, some stuff with WireMock. It does the before. It should do the after, because it's trained on the old stuff. So remember, tell it, no, stop, use the official Spring Boot WireMock thing from the WireMock team. The Shade plugin, that was a mess. So there is a module called Spring Cloud Contract Shade, which would be doing terrible stuff because it's creating a shaded jar. Shaded, like it has dependencies, all the dependencies are repackaged. And those dependencies were mainly Groovy and other stuff because I needed to avoid conflicts. Why? Because Spring Cloud Contract is a project basing on boot. Boot brings the dependencies. However, Maven brings the dependencies, and Gradle brings the dependencies. And Spring Cloud Contract has a Maven and Gradle plugin. So that was kind of a mess. And we couldn't really upgrade for years. So the difference in the dependency was rising. At a certain point, there was even a problem because, the baseline was JDK 17. Some projects in the shaded jar still were using libraries that weren't compatible with JDK 17, but actually we were not using those pieces of code. It was a mess. So the best way to fix the mess is to remove it, which I did. So I removed it. It turned out that everything works. We have a lot of tests. It simplified things a lot, cleared a lot of the dependency trees. Folder and property cleanup. I am, to say the least, not a Gradle fan. However, we have the Gradle plugin. And until fairly recently, what we had was the same approach to the folder structure. So if you had contracts, they would end up in source test resources contracts. But for Gradle, apparently, the best way to go is to have a special source set. So now the special source set is source contract test, and the old one is removed. And something that bothered the Spring Boot team since forever, because like I said, previously the project was called differently. So it was called Accurist, but it was a boot project as well. The initial properties were called, for example, stub runner, and that's it. But in all the other projects in Spring, you had the full name, like Spring Cloud Contract, whatever. So finally, with Spring Cloud Contract 5, I've decided to fix this 8-year-old problem, and you have to migrate. So if you used stub runner, now you have to use Spring Cloud Contract stub runner. It's a breaking change. What else? There was this big initiative to remove the inject and named support throughout the portfolio. So Spring Cloud Contract also had to have that removed. That was aligning with the Jakarta EE migration. This is funny. Who's using Rest Assured? Nobody. So if you use Spring Cloud Contract, you use Rest Assured. In general, Rest Assured is a library used to test the HTTP API. The thing is that Johan, who is the maintainer of Rest Assured, he did his best to not release majors every time stuff changed in Spring. Because that's also a problem. Plus, there is a cyclic dependency. Because Rest Assured uses the mock MVC API. But Spring in ResDocs, for example, also used Rest Assured, right? So we have cyclic dependency. So the idea was, how can we fix it? So what Johan did, with a little bit of my help, was that he released a major version of Rest Assured. But that happened after we released Spring Cloud Contract 5. So theoretically, we should release Spring Cloud Contract 6 to support the new major of Rest Assured, which is not going to happen. So, since already before this whole situation, Rest Assured supported Spring 5 and Spring 6, I said, why not support 7? All through reflection. So the only problem was that for 7, the return types of some methods were incorrect. So I just changed them to object, and they started to be correct, because the type is correct. So that was crazy, but it works. This is why I think a minor was released of Rest Assured, 5 something, and we could remain on the baseline of Spring Cloud Contract 5. I mean, it is what it is. Sometimes you have to go to the extremes to allow the community to benefit from not having to upgrade. Now, so that's history. I'm going to now talk a little bit about what's coming in Spring Cloud Contract 5.1, and then I'm going to switch to the most interesting topic right now, the hottest one, which is AI. So in Spring Cloud Contract 5.1, recently I was interviewed by the GoTo conference, and I mentioned that there is a class in which literally in the Java docs, it says or Groovy Docs actually. I would like to apologize to anyone reading this class. It's there. I'm not joking. And that class is called JSON to JSON Paths Converter. It's a mess. But it's a mess for a reason, because JSON as a structure can be literally a lot. A list, a map, a single value, just an array, a list of lists, a list of maps. You get the drill. So there's a pull request in which I've managed to finally, with some help of AI, to rewrite this from Groovy to Java and make it much, much cleaner. Plus, with Sprinkler contract, there is an assumption that there is no strict request matching, meaning we're not checking if the order of an array is exactly like this. Like if the array matches in general by any part of it, it matches the requirement, that's fine. Which was a problem for some people from the very beginning, and that was a valid concern. But the prerequisite was to fix the JSON to JSON paths converter to even think about doing this. So when I did the first one, I managed to do the second one as well. So it will be an option to turn on the feature of generating the strict assertions. And we have a gigantic Sprinkler contract samples repository. I updated it for boot 4 and Sprinkler contract 5. I need to do a lot of cleanup there because there's, I don't know, 50, 60 projects out there. So for those who don't know really Sprinkler contract, let me explain how it works today. And in a second I will explain why do we even need it. So right now we have a situation where we have a producer of the API or of a producer of a message. From that side, eventually, we will create stubs. But first, in order to create those stubs, we need a contract, so a definition of a scenario of usage. If we have that, then we are able to generate tests that will verify if you as a producer are telling the truth. Because imagine that you have an API, and you say, well, yeah, I have an endpoint foo, and if you send a GET request there, I'm going to respond with bar. And it turns out you don't have it. It's quite sad, right? So we don't trust you, right? Sorry. So we're going to generate a test and say, okay, let's check it out. Let's send a request foo, and let's see if you're going to respond with bar. If you do, we're going to from the contract, we're going to also generate stubs, wiremock stubs, that you can use on the consumer side. You can have contracts on the producer side in a separate repo. There are different ways to do it. The stubs, you can push them to Git, you can push them to Maven. Also, there are different ways to solve this. So now, you can ask what? Why do I need it? So without the contracts, let us imagine the following situation. Who of you has two services talking to each other? Two, just two, okay. Who has three? So you two, you don't have any services, right? You don't have services. They don't talk to each other, right? Okay, fine. So one service. Anyways, when two are talking to each other over HTTP, who of you is integration testing that? Integration testing. Okay, fine. Who of you is using wiremock or something else to simulate the producer of the API? Okay, fantastic. Who of you would say there's 100% certainty that the stub you've done acts like the production server? Nobody? Good. There's none. So the thing is, if service A talks to service B, and you're using wiremock on the service A side, so you have a class that uses REST template or whatever as client, makes a call, and if from that class you make a test and say, oh, spin up wiremock, if I send a request to full, respond with a bar. I mean, you invented that. You can write whatever you want. The stub will be there, your tests will pass. So what's better is service A talks to service B. Service B defines the contracts or has tests, out of which, after passing the tests, stubs are created, but only after we tested service B. Now, the stubs are published, and then on service A side, you say, oh, I'm not going to stub it myself. I want to fetch the stubs. I want to fetch them. And then you're sure that the stubs are telling the truth, right? So, Spring Cloud Contract works, but what if we could make it even better? Currently, as I said, we're storing contracts in the Git repo. You can run stubs from Maven. But maybe there's a way, or maybe we could think about making it even more interesting, better, to see how it looks like in a broader spectrum. So let's say that we have different apps: order service, payment service, user service, whatever the services are out there. Wouldn't it be great to have a single dashboard? So we would see every contract, every verification, every deployment, right? Anybody heard of Pact? Pact, okay. Pact Broker, rings a bell? That's a cool thing, right? We don't have it for Spring Cloud Contract. It would be great. So for those who don't know, Pact is an even older library than Spring Cloud Contract. It's a contract testing framework as well, more focused on the consumer contract side. So like, I don't want to go into the details, but it's a fantastic framework. So let's say, how about we wouldn't need to go to all those 5 repositories to check the contracts, but have them in one place. Often is the case that you can't even do it because of security concerns. For example, in banks, some repositories are not even visible to others, right? What if we had a feature called Can I Deploy? So let's say order service version 1.2.0 wants to deploy. Would it be nice to see if, can I deploy this? Like, have my consumers verified against me? In Spring Cloud Contract, you can do something like this. It's called stubs per consumer feature, which means that when you have contracts, you can organize them in folders that resemble the consumers. So instead of putting them under source test resources contracts, you would do source test resources contracts payment service, notification service, inventory service, and then you would have a subfolder for 1.2.0, 1.2.1, whatever, right? All those versions. Okay, but somebody can break the convention, right? So maybe it would be nice from the point of view of order service to be able to verify this with one command. Branch awareness. We're in main, we have contracts, we have different versions of those contracts, meaning, you know, it evolved. But let's face it, we are using feature branches. I try to have them very short-lived, but sometimes you do not. And sometimes even if you have them short-lived, you would like to, for example, check before you merge if you don't break people, right? So this branch awareness would be very nice to have, like, out of the box. In Spring Cloud Contract, you could do it by on the branch having a different artifact, maybe, right? And then fetch it, but it's not ideal. So what if the verification knew about those branches, right? It would be great. Dependency visibility. Let's say we have, you know, different apps talking to each other somehow. We have observability, like most of you raised the hand with my micrometer tracing knowledge. But what if we didn't have to wait till the production deployment and real-time flows? What if we could have it at the build time? What if defining the contracts and fetching the contracts of the producers of the API or producers of messages, what if that told us that application A uses application B at build time? That would be crazy, right? So before we go to production, knowing who's calling who. Polyglot support, the elephant in the room with Spring Cloud Contract. We do support it, but not natively. So recently, I've been working a lot with the front-end side, even the back-end side written in JavaScript. And indeed, I mean, you can do it. So with Spring Cloud Contract, we have been so far, up till version 5, because of technical reasons, we've been pushing the Docker images so that the polyglot support would be possible. So what would this do is, if you run this Docker image, inside the Docker image, tests would be generated for the attached contracts. You can see to the bottom, contracts are mounted as a volume. What would happen is, the tests would run against the application-based URL, so you'd have to start the Node app. The test would be run. If the tests are passing, there would be an artifact published and pushed to Artifactory. The same on the consumer side. You can run the Docker image. It would fetch the stubs. It works. You can do it. But it's not native to the language. So better polyglot support would be great. Now, AI. Let's talk about the AI. What if I could use an AI agent that would be able to natively speak the contract language, right? So we're using AI to generate services, but it would be great if while generating the services, the AI tool would know that if A calls B, B has a contract, right? Then automatically I meaning Claude or whatever else, could be able to already incorporate the contract tests, right? After having done that, they could theoretically publish the verification result. Hey, I'm fine. I can talk to you. So at this point, there's nothing machine-friendly for Spring Cloud Contract, right? No MCP server, no API for agents. What if we could stop wasting CI? This is really interesting. Like, let's say that we have a couple versions of our code. It happens. We release stuff. What if we didn't change any contracts? Why should we run the tests? API didn't change. Contract tests are not about going end to end. So if you've done things properly, so you have a controller, you have a contract tests, controller delegate work to service should be stopped. If you're doing it like this, there's no point in running the tests again. They have to pass if the contract didn't change, right? Because contract tests are about semantics. They're not about the features, right? It means, like, can we talk? Will we be able to talk in production? That's what contract tests are about. So if we have same content, why verify again? So we could skip it. So we can use tools to generate the services in minutes. The question is, who writes the specifications, who verifies the contracts, right? When I'm teaching about testing, I've been doing that for more than a decade now. Especially now in the age of AI, nothing was more important than tests. I mean, always nothing was more important than tests, but now it's even more important. I think that generating code with AI, it's a little bit like you have a river, right? The river is flowing. I mean, you can go inside the river and say, like, you shall not pass. You can have a stick and try, stopping it. I don't think it's going to work. But you can try to control whether it goes left, right. So that's the same thing with AI. AI is like a flood of non-deterministic stuff, but you can have guardrails. Contract tests being one of them. And I have a course, by the way. I have a QR code to that course, Generate, Break, Fix Distributed Systems in the AI Era, about this. So without the contracts, we already mentioned what the problem will be, right? If you don't have contracts, you can have tests that pass and production doesn't work. Now, with AI, if we have the contracts, AI can create proper specifications of the communication even, right? Because it knows the scenarios of usage. It doesn't mean that let's say you do not replicate the business logic in the contracts. You should not do it. But you can have specifications about how the communication should look like. And that can be taught from the contracts. Now, Tom Akehurst is an amazing fellow. So he's the person behind WireMock. He's the founder, creator of WireMock. He had a fantastic, fantastic presentation called Scaling API Independence at QCon. This is the link to his presentation. And what he said there is that he has this idea. He thought about, like, how can WireMock better work with AI? So he had this idea. In production, you don't talk directly from A to B. you go for a proxy. And now, that proxy is the wiremark proxy that captures the traffic. Of course, PAI, we have to get rid of this data. And it will create stubs from production traffic, which means I don't have to do it myself anymore. It's taken from production, right? So let's talk about that idea in terms of Sprinkler contract. And in general, Sprinkler contract and AI, because we could theoretically do the same. Now, contract as AI code in context. What if we had an AI agent? We're writing a new consumer. And now, AI agent can go to the MCP server and say, what are the contracts for the order service? Because I'm going to consume that service, right? And you get back a proper contract, for example, right? So that way, contracts become the AI's pair programming partner because they describe how the communication should look like. And that's verified, right? So the agent reads the contracts, generates the client basing on the contract. And the verification against that provider can happen through MCP tools. We can do it. Another case, you have brownfield. You have billions of Spring controllers. So you can say, oh, just no problem, just write tests. I mean, you know how it is. Like, who here, I mean, we're friends here, everybody's, about tests. Who always starts with the test? Okay, let me repeat. Who always starts with the test? Nobody? Okay. Neither do I. But we do write tests. But there are places, very dark places, where there are no tests. So let's try to fix it. What about an AI agent reads the code, the Spring controllers, reads the annotations, and from that tries to generate the contracts, examples of usage, and in a loop. Try it. Okay, now I have it. Try again, I have it. And that way, automatically, you could create the contracts. So we inverse the spec-based development. That's perfect for brownfield. Another thing we could do is tweak it for the controllers, ask AI to generate mock MVC tests from which, using ResDocs, you can generate stubs. Sprinkler contract allows you to do it. So that way you would have tests, from the tests you would have stubs. And also, you could generate contracts. It's possible. Okay, what about we had such a situation? You use Claude or whatever else and you say, I need to do some serious work, some serious coding. How about I just talk to Claude and say, hey, just create a contract, post this to orders, there's going to be product ID quantity, get back to 101, blah, 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 bye. And then, boom, you get the contract. With proper MCP approach, like the tools, that's absolutely feasible, right? So for non-Java teams, or anybody really, you lower the barrier completely. I know product owners and business people, business analysts that talk JSON, right? They literally, okay, that's interesting. Definitely they're wearing contract tests here. Okay, what about contract drift? This is also very interesting. Let's say that exactly in this part that you can't see, let's say that we have some production traffic and we capture it all the time. So there will be some sort of a proxy somewhere, right? And we do an analysis of what we capture in prod versus what we have in the contracts. And then we say, oh, you know what? I see a problem. Because in the contracts, we say, for this case, there's 200. But I found that 15% are to 422. What do we do about this? It can be done as well, right? So contracts, because contracts always describe intent, but traffic is showing the reality, right? So we can have some intent and then verify it against the reality. So AI can be our pair programming partner saying, there's a new field here that we didn't take into account. The status code, okay, most of the time is what you say, but there is an ongoing problem. So we can see those patterns before they become production incidents. Another thing, somebody comes in the morning, says, oh, it's a great day to delete something, right? And that person hasn't listened to any of us for the last 20 years saying, don't touch the API if you don't have to. Somebody says, this legacy ID field, I need to remove it. Okay, what if the agent said, you know what, it's a fantastic idea, but don't do it, because there are free consumers that use it in these versions, etc. This is exactly why we have contract tests. This is exactly the point. You can already have it right now without AI, because if you do stop per consumer feature and you remove a field from the API and you run the contract tests, they're going to break and tell you the field is missing. But what I could do it before, like I'm going to describe the intent. I want to remove it, and it's going to say, don't do it. So, the one that Tom mentioned, can we do it? So we have HTTP traffic, we have some sort of a proxy. Now we have AI. So let's say the proxy batches the request. Then AI takes of course we have to remove the PII, so personal identification information. We take those, and from those we generate the contract. And now somebody can say, yes, but AI can make mistakes. Fair enough. So what's the solution for that? A loop. But to do a loop, how can we say that the contract that the AI has generated is wrong? We can have an OpenAPI validator. So let us assume A talks to B. Each of the services describe their OpenAPI schema on an endpoint, /OpenAPI, for example. So now AI generates the contract, and using the Sprinkle Contract OpenAPI validator, it can check if the generated contract is valid against the schema. If not, repeat and loop until it's done. Right? So the schema is the source of truth, but schema does not provide testable scenarios in the way that Sprinkle Contract does. So we can do both. So if it's invalid, go back to AI and say, no, these fields are wrong. And it will loop, loop, loop until it's matching the spec. So what is the full picture with contracts and AI, the way I see it? So AI can read the contracts. MCP server can help us. It can feed the contracts as a context. Agents can generate proper client code. They do not have to guess anything. AI can write the contracts. It can read the annotations. From the traffic also, right? It can capture the requests. AI validates the contracts in a way that is repeatable, deterministic. And AI can monitor the contract, so impact analysis and drift detection. So there's a lot we can do with AI. So in essence, contracts are the interface between humans and AI agents. So what if all of these could be available in one place? So central dashboard, can I deploy safety, branch awareness, dependency graph, polyglot SDK, content hash dedup, governance layer, and AI contracts. And now, ladies and gentlemen, you're the first. Oh, I ordered that exactly at this point, at that hour, to witness something which is called stubborn. Stub-born? Do you get it? Thank you. Stub-born. I am so bad at that jokes. So what I did is I created stubborn. Version 0.10 is there. And maybe not every, but most of the improvements, for sure every improvement in terms of the topic is there. In one product. You can go check out demo.stubborn.sh. It's there. Don't break it. So you have this completely invisible for you central dashboard. So you go in, you see the dashboard. By the way, it's not a sales pitch. I just want to show you that you can already benefit from some things. Plus, there's I'm going to later describe why a separate org is required because of technical reasons. A dependency graph, I love it. So it shows, like in Pact, who is calling who is failing, but the purple one and the blue one is showing messaging. So it's saying that order service talks to the notification for service through order events. This is awesome. Can I deploy safety? So you can say, hey, API gateway in version 1 at staging, can I deploy? No, because you didn't verify against payment service, notification service, and inventory service. AI proxy is there. So you can start the proxy. You have to provide some OpenAI key, for example. Now, you have to send a request so that we know where to target it next, right? Because you're going to talk through the proxy. So an app will talk to the proxy, and then the app has to say where the traffic has to go. Traffic gets captured. We're batching the requests, converting to SCC YAML. And stubborn open API, that's a project, open source project, will do the validation against open API specs. Because Spring Cloud Contract, for years now, had a community project that allowed you to define contracts within open API spec in the examples section. So I took it over to the org so that it's in one place. And I've added a feature there to do the validation of against the open API spec. And now, contracts can be pushed to stubborn, because stubborn allows to push the contracts in various ways. Now, this is also nice. So we had a proxy for messaging, for HTTP. What about messaging? What if we have, for now, Kafka? I don't have more time to do Rabbit. It's in the plans. Let's say we have Kafka with existing cluster. What if we have a passive listener on consumer group, not competing for messages, not acknowledging them, just picking? It's looking at them and generating messaging contracts from the actual traffic in production. And you can store them in stubborn. This verified piece will happen, but I didn't yet have time to properly do it because we would need to have some sort of a schema for the messages. And there are ways to do it, right? Avro, protobuf, it can be done, right? Contract API guardrail. So we have stubborn open API. You don't need to use the broker at all. It's there. So what you can do is validate contracts versus open API. It will detect missing endpoints, wrong status codes, schema mismatches. You can convert from open API to Spring Cloud contracts. So in other words, if you write the Spring Cloud, open API contract the way Spring Cloud contract understands, you get all the benefits of a Spring Cloud contract. There's a JUnit 5 extension even, that if the contracts drift, it can fail. And it becomes a proxy guardrail, as I mentioned. Polyglot. First of all, we have a dedicated plugin, stubborn publish contracts for Gradle. For me, already using Gradle is polyglot, because of, but these are my personal problems. But what about Node? What about Node? Start publishing using Node native libraries. It's there, it's in NPM. You can say, I am order service in this version, contract, publish them. You want to use brew? No problem, the CLI is out there using Graal. You can do brew install. There's scoop as well for Windows, right? You can use it. So if you want to locally say, hey, can I deploy? No problem, use the CLI. The MCP server is also there. So you can ask it, like, check if order service can be deployed to production. So how does it work with Node.js? So in Spring Cloud Contract, you had auto-configure stub runner, and it would fetch the stuff. So in the Node world, I'm not a Node expert, by the way, but from my understanding, this is the way to go. So you import setup stubs, turned out stubs, and you say, the broker is there, I want the stubs of that app in this version, and it will start them. So this is an example of a test that tests if the stubborn jest integration works fine. What about, so actually what I did is now NPM understands wiremock. It can read it and run it properly. Also, Node knows how to fetch Maven jars and unpack them and make them work. Now on the producer side, you have the verify contracts. So you have to provide some things. And what happens is that if the producer is not correct, you're going to have the assertion message like what is not correct on the producer side. And if it's correct, it's going to report the results back to the broker. What Stubborn can do is normally, let's say, the stubs jar, the contracts are in Artifactory Nexus, so you can import them into Stubborn. And then for StubRunner, you can say, fetch the contracts from the broker. What you can do is literally point to Maven and say, in Stubborn, just download them. But the funny thing is that also Stubborn has the Maven API. So literally for you is to just change from the existing Artifactory to Stubborn and it will work. Right? So one config change, stubs come from Stubborn instead of Artifactory. This is the only change you have to do, assuming that you migrate it to Stubborn. So you don't have to do a big bang migration, which is always a problem, never works, so you can do it gradually. So you can get started. The Stubborn broker is there available as a Docker image. In my org, I should have done it like not M. Grzejszczak. I should have done Marcin G. That would be easier, I guess. If any of this gets traction, I will have the financial opportunity to buy in Docker and org, but I don't yet. So for now, sorry. So there are ways to start. Now, why Stubborn? Because I am not a maintainer per se. I don't have commit rights to Spring Cloud contract. I have to work for pull requests, which is fine, but the Spring Cloud team has a lot of work. I know it, I've been there for decades. So I thought that it's a good idea to have a faster lane, like a quicker one, to see if stuff have traction. Because if they do, and they're more mature, we can file a pull request to Spring Cloud contract, right? So Stubborn will be the fast lane. I can ship stuff to Maven Central. It gets feedback. It's more mature. Then I can file a pull request to Spring Cloud contract. I can release every day, every week, every month. In case of, Spring Cloud, we have to wait for the 5.1 release, which I have no idea when it happens. And it's possible to be found 6 months, maybe, right? Why wait, right? And if we can test it in the meantime, then we can contribute back to open source. I mean, AI is here to stay. AI is awesome. I love it, except when I tell it like, Claude, Maven clean install. This is literally what I said. I didn't write anything else. I just wrote Maven clean install. And what did Claude do? It said, no problem. And I'm looking at the command, Maven clean install skip tests. I'm like, where did you find it? I didn't write it. So, but anyways, AI is awesome. So we need the contract tests to be also available for AI. And this is my personal opinion. Contracts and all sorts of tests become more important than ever before. With AI, we can generate so much code of different quality, let's call it like this. Regardless of the quality, it needs to work fine. The guardrails are the critical piece, and contract tests are a very good guardrail. So I am working recently is for example, have an app that has front end and back end. I start with the back end. I do ATDD, acceptance test driven development, and I tell whatever the LLM I'm using, this is the business case. Start with the API. Do mock MVC tests, add Spring Cloud contract, start generating stubs. I go through the backend cycle. And then, when I do the front end, I say, these are the stubs. Write in the whole front end from the business case against the stubs. You don't need the backend now. And it's super fast because these are wire-mock stubs. They start in no time, right? And that way, I am almost certain that the communication will be fine. Of course, afterwards, I add also some end-to-end tests for the sake of checking if the Docker container is starting, et cetera, but this is critical because even for AI, the fast feedback cycle is also important, right? You don't want to wait until end-to-end tests fail, but already have the guardrail of contract tests. That's it from my side. We have exactly 4 minutes for questions. Now, I leave you with a couple of links. To the left, you have stubborn.sh. To the right is my Maven course if you're interested in how to generate, break, and fix AI stuff. There are the docs stubborn.sh as well, the demo, my blog, toomuchcoding.com, and there's the org stubborn.sh, because of course somebody took the stubborn one, so I had to do it with a -sh. Okay, any questions? Like, do you have questions? Yeah, go ahead.
Why is there a contract YAML and an open API spec YAML? Aren't they very similar?
So the question is why there is an option to have a Spring Cloud contract YAML and an open API spec. So open API specification is a schema. It doesn't describe proper usage. You can have examples, but it doesn't describe like how to use it, but what is there. If you think of consumer-driven contracts, if you have a consumer A that wants fields 1, 2, and you have consumer B that wants fields 3, 4, one doesn't care about the first two, the other doesn't care about the second two. So the fact that you have a schema that describes all of the options is unnecessary. I mean, to some extent. But there's no problem in having the open API schema with the X-contract extension where you describe the usage. So you have the schema, you provide the usage, and then Spring Cloud Contract takes the usage and generates tests out of it. So you can have either this or that. You shouldn't have both, really. That doesn't make sense. Like if you have the schema, just extend it so the Spring Cloud Contract understands, and then you start benefiting from Spring Cloud Contract. Does it make sense?
I thought, okay, we have a lot of open API specs.
Very good.
And I thought maybe that's just enough to have a contract for the others, or others can see how my service works or what it offers.
So if you have, so the comment was, we have a lot of open API specs. So if you take them and provide the X-contract extension saying, if I send this, I get that. If I send this, I get that, you're done. It will work. I mean, technically you have to point there. You get the idea, right? I mean, you have to plumb Spring Cloud Contract in it. But from the point of view of what we need in the open API spec, that's exactly it. Just tell us how to use your stuff. Because we know what you have, but we don't know how to use it. Again, it's not a replication of features. So let's say we have a fraud detection app that verifies given different things, verifies whether you're a fraud or not. Let's say from the business perspective, you can be a fraud for 100 reasons. I presume you would have 2 contracts. You're a fraud or not? Because I don't care, like, what is your business logic? I care about semantics. So I understand I have to have those 10 fields, fine. And now let's say if my name is fraud, then I get like 401. But if my name is Smith, I get a 200. And you test those 2 things. Any more questions? Any questions? No questions. Okay, so we're exactly at the top of the hour. I mean, at the end of this presentation. So thank you very much. If you have any questions, I'm still here. And I would say enjoy the rest of the conference, but it's not a lot of conference to enjoy. But still, enjoy that part and enjoy Barcelona. Thank you.